Morning, everybody. This is a solar and space environmental awareness briefing for 24 April 2015. We're going to start with something interesting that we found on the sun this morning, and that's this arc prominence on the northeast limb of the sun. It's not associated with any active region. There's an active region close to here, but it's not associated with it. Arc prominences are suspended plasma held aloft by the magnetic field. What's interesting about this one is that it's visible in not just the 304 angstrom helium-2 image, but it's also visible in the iron-14 image, the iron-12 image, and the iron-9 image. And what's really cool is you can flip back and forth between these, and your eyes are able to pick out structure in something like an arc prominence by flipping back and forth between different images like this. That's kind of interesting. Arc prominences, since it is suspended plasma held aloft by a magnetic field, they can erupt out, and they can, if geoeffective, impact the Earth. We had a geomagnetic storm 2 weeks ago that was caused by one of these erupting, but of course that was on the western limb of the sun. This erupted towards the Earth and gave us a small geomagnetic storm. This is an interesting thing on the surface of the sun. Let's go to our visible light image. What you see almost dead center on the disk of the sun is what looks like a really nasty solar active region, but what it is actually two regions that are not associated. 2331 is just a beta, 2327 is just an alpha, and as you can see on the magnetogram, they are not magnetically connected. We usually do an analysis of these using multiple magnetograms at the observatories, but we can do a quick analysis here using the iron 9 image. Where my cursor is what I'm circling here is actually the 2331 region. 2327 is just this region over here. And as you can see, there's no real magnetic connection between them, so we don't associate these two regions magnetically. Let's look out into the solar wind. You can see pretty much nothing to worry about in the magnetic field. The field is strong, but it's not south, so it's not aligned with the Earth's magnetic field. We haven't seen any shocks in a while. So but this magnetic field, since the speed is high, is usually associated with a high-speed stream, and we did have a passing coronal hole, so we're still in effect of that solar wind. Looking back a couple of days, we only had one small period of KP around 4. Otherwise, it's been relatively quiet. Looking at our GOES X-ray flux, we had one long-duration C flare. These long-duration flares, if geoeffective, can cause us trouble because we generally get an idea of how much energy is in the flare by how much area is under the curve. So even a low-intensity flare that's a long duration can give us a large particle flux, damaging satellites. So let's look at our forecast. We're looking at pretty quiet probabilities for this next couple of days. This is average for this time in the solar cycle. Nothing dramatic for the next couple of days. And speaking of the solar cycle, I have over here on the left the latest solar cycle progression plots. As you can see, the current solar cycle is a lot less intense than the previous solar cycle, and here we are right now on the downswing. We're heading into solar minimum. And one thing I wanted to show you is solar cycle progression can be measured different ways. We typically measure it with sunspot number. That's the way we've been doing it for literally hundreds of years. But the 10.7 centimeter radial flux is a good proxy for sunspot number. So if your observatories are clouded out, in the old days you would use this radio intensity. And you can see we're also on the downswing. We can kind of get an idea of how the solar cycle is behaving by looking at the effect on the geomagnetic field, and you can see the previous solar cycle had a much larger effect than the current solar cycle. But these trends don't always track with sunspot number or F10.7. And that is our briefing for 24 April 2015.